on geospatial visualization and processing. And first session is by Shreya Bobde. She is going to talk about enhancing the layers platforms with the high performance 3D visualization. So please welcome her, and we'll go ahead with the next talks. We'll have to spend some time in between for setting up the environment and the laptop, but please have some patience, and we'll start with the next talk shortly when she finishes. After she finishes, we'll have some 5 minutes question answer session as well, where you can ask your questions and she'll be replying to those. Yeah, please, Shreya.
Hello, good morning everyone. This is Shreya from Nascent, and I'm working there as an associate software engineer. And today I'm presenting my work on enhancing the layers platform with high performance 3D visualization using Margo 3D and CesiumJS. So as we all know, 3D data, explosion in 3D data has been, there is a large explosion in 3D data, and but we have a limited ability to use it in our day-to-day GIS workflows. So this was the motivation for me for this work. So what is the difference between 2D and 3D? As we all know the basics, like in 2D we have two dimensions, X and Y dimension, which limits our understanding to the planimetric views. Height is either mentioned indirectly or either missing. 2D is basically good for surface-based analysis or basic visualization, but what it lacks is modern urban and infrastructure. In contrast, 3D, we have X, Y, and Z dimension. We can have terrain-aware context. We can perform volumetric analysis. We can plan urban infrastructure, and it's not only limited to visualization. We can also perform analysis on that. So what lead to the expansion of 3D in GIS? So as we all know, there are some limitation to 2D. Like in 2D GIS, 2D GIS struggles with the vertical and volumetric spatial relationships. At the same time, there are some technologies like LiDAR, UAV, beam, which are have made rich 3D data widely accessible. So this increased the demand of 3D in urban structure planning and infrastructure workflows, as they require terrain-aware and object-level spatial understanding. But at the same time, as I mentioned earlier, there are mostly GIS platforms which are still 2D centric, and the gap between the availability of data and capability of GIS has driven the expansion into web-based 3D GIS. So what are the challenges in 3D data? So 3D data, as we all know, is larger in magnitude as compared to 2D data, which really hard to manage and store. Then managing levels of detail with ensuring the performance without sacrificing the quality, data integration. In GIS, we often consist data from heterogeneous sources like LiDAR, UAV. So we have also assure and align it across the data sets. Then the complexity in generating 3D tiles from the raw data. Managing and updating 3D data sets remains significantly more complex than in 2D. So it should be scalable and maintainable. Then we have to preserve semantic like attributes and relationship. Also, while rendering in web browser, we have to look after constraints also, like speed and managing GPU memory and network constraints also. So there is a technical gap in existing GIS system, like rapid growth of LiDAR, UAV beam, and 3D CT datasets exceeds traditional GIS design. 3D data is available but not usable at scale in operational workflows. Desktop GIS supports 3D but lacks scalability and web accessibility. WebGIS offers access but struggles with performance for complex 3D data. Most platforms remain 2D centric with limited native support for large 3D content. Poor integration between OGC-based GIS services, terrain, and 3D objects. So this leads to the problem we sought out to solve, like integration of 3D leads to the struggles we face while browsing the large 3D data sets. Then we have to integrate in our 2D GIS platform seamlessly, converting 2D GIS data to 3D GIS data efficiently, and not only visualizing 3D data but also performing analysis on that. Last, it should be scalable and with a good performance, so it should consist of both 2D and 3D. That was our aim for this work. So Nascent has their own product layers. It consists of two separate platforms like admin portal and geo portal. So basically what we do is in admin portal, we create projects, or it is basically for smart city, and we create different projects, different departments for cities and municipal corporation, upload data, manage data, and all that stuff. And we visualize all that data we have uploaded from admin portal on our geo portal, where we have different modules as well to analyze data we have uploaded, perform different analysis like query the data, performing buffer. We have different facilities like printing the map, and finding nearest landmarks, fastest path, shortest route, all that. So Layers is basically OGC compliant platform. It manages data very efficiently and stores the spatial data. It visualizes data with geographic data, and we can add styles and beautifully visualize it on there. The tools we provide on our layers is very good for decision making. And the next, we have the objective was to extend our support from 2D GIS to 3D GIS, having both at the same platform. So for that, the major challenge was to how to convert 2D data to 3D data. For that, we have used a different open source tool, but at the end we have chose Margo 3D. So why we choose Margo 3D is it is designed for city and regional scale 3D GIS, whereas other tools are limited to small and medium data. It supports terrain, 3D objects, LiDAR, and extruded GIS data within a single framework. Optimized 3D tiles with LOD-based progressive loading. It preserves GIS structures and workflows, whereas some other open source tool might lack that. Open source and integration friendly with existing GIS platforms. Other open source tool are we can use them once and they get off, so we have to on and off that. But in Margo 3D, we have embedded it very smoothly. We can use it repeatedly, and it's very good. Seamlessly integrate with CesiumJS and 3D visualization analysis. The tiles we have generated from Margo 3D are very good, and it easily gets integrated with CesiumJS. So how we worked on it? We have an interface in our admin portal where we usually ask user what they have to generate tile or terrain, or what name they have to give, or the projection they want their tiles in. After that, the user uploads their data, and with a backend API, we have a Margo 3D processing command which get executed, which converts tile to 2D data into tile, and after completion of that, we store the entry of like name and other stuffs like projection and all in our database. And the 3D tiles we have created, we store them on our server. Then we visualize them in on our geo portal, and this data has fetched dynamically, and with the help of CesiumJS, we render it. So as we all know, CesiumJS is an open source, and it is very good for globe and terrain rendering. We can navigate camera, pan, zoom, Uh, we- it also supports spatial reference handling. Margot 3D integration is very smooth there, as tiles get very easily render, and we can also have real-time interaction there. It is browser based, and it helps us in developing many tools like measurement tools and line of sight and dynamic slicing tools. So 3D analysis and measurement capabilities. So we have developed 3D analysis tool like line of sight, and which considers both terrain and 3D. क्या हुआ है? Then we have developed 3D measurement tools like measuring distance, area, angle. We have developed a tool for performing slice analysis. We have developed a tool which performs query on 3D tiles. So it is designed for practical decision making, and these capabilities bridge 3D visualization and operational GIS workflows. So here, this is our measurement tool for measuring distance, where we have also added different units like meters, kilometers, and other units, and we can perform distance, and we can measure distance. We can measure angle as well in degrees and radians. We can measure area in different units, meters, kilometers. We have added other. So this one video is for the query module we have developed. In this module, we can select the 3D tile layer, and from the attribute we can choose whichever attribute we want to query, then use the operational tool. And like here I have filtered for residential building which have type residential, so it get filters out. We can perform for, we can type or use different tools for that. So this is how I have developed the query module to query 3D tiles. Then we have also developed our tool for slice analysis, in which we have developed slice analysis at different, for horizontal, for vertical, and for at slice at different angles as well. So this one is for horizontal slice. This one is for vertical slice at x-axis. Next is a vertical at y-axis. Next, this one is at different angles. We can give input the angle as an input at which angle we want our slice plane to be. Like here, I have given 50 degree. Then we have also developed a tool for line of sight. Here we have to give the location of an observer and target location. So what are the outcome of this? We have web-based access to large 3D datasets enabling faster spatial interpretation. We have unified 3D and GIS workflows, and we have reduced reliance on desktop-only tools. And what are the applications of this? We can use it in urban planning and governance, in infrastructure review, in utilities and telecom planning, and in environmental and emergency assessment. Concluding this, the rapid growth of LiDAR, UAV, beam, and 3D city data has made 3D GIS a necessity, not an option. By integrating Margo 3D with layers and CesiumJS, we extended existing GIS workflows into 3D without disrupting the 2D backbone. A scalable web-based 3D architecture enables efficient tiling, terrain handling, and browser-based visualization. The purpose-built 3D analysis and measurement tools transform visualization into actionable insights. The result is a unified 2D, 3D GIS platform that supports real-world planning, infrastructure, and decision-making. Thank you.
Yeah. Now we are open for the questions. Anybody who has questions, please let us know. Just a minute, sir.
What do you mean by not for academic complexity?
By that, it is not for centric to academic purpose only, and we can use it in decision making and urban planning as well.
Product is ready to use now. Product I can use if I buy product, whether I will be used readily.
Yes, sir. Sorry.
Is the product is ready?
Not yet. We are developing. We are working on it right now. We are working on other analysis tools as well, developing different tools. So for here, our major challenge was to integrate 3D in our already existing GIS platform, 2D GIS platform. So that was the major challenge for us. And after overcoming that, we have developed different tools, and we are still working on it, and we are still developing different tools.
Okay, madam. With reference to your title, can you say what is the relevance of high performance as well as scalability?
High performance here means, like as I mentioned, we have developed tiles from other open source tools as well. So by using generating tiles by using Margo 3D, the tiles are very lightweight, and it has really good performance. It renders really fast, and while we perform other analysis tools, it really supports and give faster results. So that I mean by high performance, which it lags in other open source tools. It also preserves GIS data, while some other tools might not. Some other tools are limited to small to medium data sets, but it usually can handle large data sets as well.
How large?
Like city scale or regional scale.
Petabytes, terabytes, how large? Terabytes. With reference to data.
I guess I'm not really sure, but I'll get back to you.
I can understand the difficulty because still the end to product is, I can understand. But these are the things which is occurred when you say high performance. And scalability, I'm not getting it. What do you want to do? Scalable solution. But it is a very good software need of the hour. Some amount of efforts has to be put. With reference to high performance, I feel still many things has to be worked out.
Okay, we will definitely work on your.
Yeah, so someone from the nascent team, if they want.
Hello. Yeah. So there are basically two aspects for the high performance. The first one is like how quickly you can generate the 3D tiles. Okay. So we have used other tools, and like especially we were facing the issue for generating the 3D tiles for the underground utility data. Okay. And like what was the software we have used for that?
FME.
Yes, FME we have used, and it was taking like hours and hours for that. But we have checked with the Margo 3D, and within like minutes it generates the 3D tiles. I mean, you mean to say the hardware? I mean, the hardware, what was the processor we used and the RAM?
Yeah, we have tested with GPU and CPU both. Okay, normal laptop and workstation on a workstation both. It's working with the GPU as well and CPU as well. Yeah. Just requirement of 16 GB of RAM. In a yes, yes, you can use in your laptop. Okay, and generate the 3D tiles.
Yeah, any other questions?
Yep. Hello.
Hi.
So the Mago 3D, uh, uh, the Mago 3D is the product of the Korea, so I have really curiosity about it. How do you find out Mago 3D, and was there any other options we compare with Mago 3D?
Yes, it's a Korean-based company, Gaia 3D, Mago 3D is their product only. And I didn't get your next part of the question. Can you please pardon it?
Was there any other 3D map options? Have you ever compared with the Mago 3D, the other products?
We have used FME earlier for our underground utility. So it used to take hours and hours to develop 3D tiles, and as compared to Mago 3D, comparing Mago 3D with FME, Mago 3D generates tiles really faster, within minutes, I guess.
Thank you very much.
Anybody for questions?
You must have used the CesiumJS basic capability of 3D rendering.
We have used CesiumJS, not used iron.
Okay, so for CesiumJS also it provides you the capability to import the DM.
Yes.
So can you compare the performance of Cesium native capability vis-a-vis to your Mago 3D?
Yes, we can.
Any comment on that?
We can compare, but right now I have to study on that on Terran part. Right now we have generated tiles from vector. We are working on developing tiles from raster dam and Terran tiles.
So you mean to say that you have generated the tiles only for vector, not for the elevation
We are
part?
working on it. We have generated tiles, but we have to still include it in our product.
Okay, thank you.
Okay. Anybody else? Okay. Thank you, Shreya.
Thank you.